Welcome to Utility AI Framework, designed to make it easy to incorporate Utility AI, a flexible decision-making system that allows agents to select actions based on a list of considerations. Best action. We make sure it is easy to extend, understand, and to debug. The package comes with 3 demo scenes. The first one is turn-based, like Pokemon. There is an agent with 3 actions: normal, water, fire. When you click attack, it'll pick the best move. What do you think the water monster will do against a fire monster? The water spell. Why did it do that? The element score of 1. The fire spell has the lowest score, as you can see. Why is that? The spell element score is 0.1. And it can just keep attacking. The other demo scene is the village hero simulation. In this scene, there are 2 heroes. They can both eat, work, sleep, slay monster, and buy a sword. So unfortunately, these heroes don't start off with a sword. We have a blacksmith who wants to give one of them a sword. The other hero has to work for it and buy one. Here you can see the heroes are working by cutting these cube trees. A monster has appeared. Hero 1 just wants to finish up eating, and the blacksmith just gave him a sword. Now he wants to slay some monsters. Hero 2, unfortunately, is still busy working. He only has 2.1 amount of money. When he earns 3, he will go buy a 3.1, he'll go buy a sword. But he gets sleepy as he works a lot. He can rely on the other hero, so he's just gonna go sleep and back to work. He just needs to cut one more tree and he will be able to buy a sword. The sword check if there is a monster. Sorry, the buy sword checks if there is a monster. The final demo is the onboarding scene, which is not very appealing, but is very simple and easy to learn. When you press play, the framework makes it easy to add and modify properties without touching the source code. Right-click, Create, Continue Studios, Utility AI, Properties, Property Set. New property set. In a property set, you can define any kind of property you want. You can create add a U float and call it HP. This is an accessible via code on the agent. For example, we have a method called take damage or deal damage. Now the agent dot property set dot tries dot set, we need to determine what type it is HP minus 1. just like that. We can set the HP.
So today I'll be showing you one of the character in the game that I will be converting it to AI utility. So let's just first will take a while. Cool. So in my game there's this character here. His name is Noah, and when you move, he follows you. In combat, you're able to select a target. Right now you can't, but we'll be doing that too. You can in the current game, just not in that state. So I'm just going to move here where we're not engaged in battle. When he moves, he doesn't always necessarily move linearly. He has his own sensory system, and because he's a flying type, we can't use that mesh as well. So I'll be showing how to implement our own custom move system or use an existing move system. In the game, you can tell him to follow you, and he'll teleport and then follow you. You can tell him to sit, and you can tell him to target something. You can target yourself. It's a little game you can play with him. Parry. So in this fight, when you pick up this item here, Noah will teleport in front of you and tell you to throw it at him. And then, I can show you this now. You can select an object, and he'll go there and attack it. So we'll be rebuilding him from for the allocated time, but I think we can rebuild the whole thing. But I can at least show you how it will work. I'll quickly show you how it was set up previously. Obviously very crazy, as in not very scalable. He was a prototype. Let me just open up the script. So currently Noah is built a bit like using a finite state machine. It's non-elegant implementation, was just using enum, and then the Noah companion class would handle almost everything that it needs to. So we have a current state, and it sees if you're in the help state, it'll do this. If you're in the follow state, it'll do this. If you're stay, it'll go sit, it'll go special, and so stop none. So when he receives a command, he would transition to a state based on that command. And then we'll just play an animation. So yeah, let's get started. I'm gonna create a new game into game object, and I'm just gonna call it Noah utility AI agent maybe. And I'll place them both at 0, 0. I'm gonna turn this Noah back on just for a moment so we can see him. I'm gonna place the camera so it's a bit closer to him. Maybe here-ish. Maybe top down-ish so we can see. Is that what? So now, in Noah utility AI agent, we will be creating a new entity class for actions. I like to store my actions as I like create like a container for actions. So I'm kind of just thinking on a high level at this point. Oh yeah, he could have said shoot, which was when he was attacking. So let's attach an agent class on it. Is that the correct one? I like moving agent on top. This, okay, when I look at this agent, I want to read the agent, not the utility. I know. So a few things that's interesting about Noah is Noah receives a command from the player. So this means it's almost like when he receives a command, that's when we want him to update. So we want his update time to be driven by the script instead. Or we can do update as well, which is a bit more which is a bit tricky. So let's do update for now and see where we go. For now, Noah will keep everything the same, just the default. We need to, let's first get Noah to follow Alex. So let's create a follow action. Follow. And we're going to pretend Alex is this 3D cube here. So when I prototype, I like to just I guess make sure it's working in a very simple way. Let's call this the player. And then later we'll bring Alex into the scene and all. So the follow just needs to be, we need to make a follow action. So I'm going to go into the project and just maybe make a folder for utility AI. Utility AI demo. This can be the Noah demo. Noah demo. Noah demo? Yeah, sure. And here's a folder for scripts. And I'll make a class called follow action. So I'm just namespacing it for now so that there's no I'm gonna try this example. Revise. Don't need this. So here we're just going to implement from utility action, and it will force us to implement a method. The method is perform. So in perform, we can return the action that is complete immediately, and just log it out. So when setting up my agents, I like to be very deploy. I like to do one thing and make sure it works. So here, I will go here in my follow action, and the action name will be follow. The weight can stay as 1. I'm on 2022.2, so there was some weird bug there where the start and the little circle icon didn't show up. I don't think that matters. We have the follow action. We can see the follow action exists. There's no considerations. So let's add a consideration. We have to make a brand new one. So I'm going to go to follow action. Like, what would be the consideration for following? So earlier you remember that the player sends a command, and when Noah receives the command, he would follow. So I think a class called has command consideration might make sense. The idea behind it is we'll have a type here, command type. Now if the command type matches the command that we receive, so command received, which we will get from the agent or the action later. Under the demos, under the Noah demo, I'm just going to go create utility AI examples, Noah considerations, command consideration. So let me just create a scriptable object. I'm going to call this a follow command consideration. And we're just going to make sure we choose the type to be follow. So I'm going to add a description for it. Should Noah follow Alex? Alex is the main character. So right now in the script, we pretty much just return 0 or 1. We're not even using this response. So let's use this response. So I'm just going to var response value var score equals this. Yep. So this will equal to the score, but what we return is actually the response curve dot evaluate of the score. What that does is it takes the score we want and place it on the curve here. So you see the response curve has a linear line. So this will be input 0. It will be exactly 0. Input 1, it will be 1 value. The way this graph works is the x-axis is the time, the y-axis is the value. So if you want it, so when we put 0 here, if you want the command to actually be, let's say 0.5, set to 0.5, and that will be, it will output as 0.5. And you can see here, when we add a simulated value of 0, it's 0.5. 1, it's 1. This is just an editor tool I wrote to visualize this, because it could be a bit tricky. Anyways, I'm going to set it back to 0, because we Don't need it to be dynamic or have code. So go back to our action, or actually attach the consideration. Just drop that in. We'll save again. So I'm gonna turn this off for now. Hopefully it doesn't bite me. But we're kind of ready to press play to see if the log will appear. So I'm going to press, now let's press play. And we can see here the log is constantly following. But we don't want the follow action to just constantly call follow. We want it to do like the constantly complete, because if we look in our plan, I'm going to turn on show log. And I'm going to show the plan here and pause it. We can see that Noah found a plan follow, he completed it, and he found that plan. So he's constantly replanning, but he hasn't even reached his target, which we don't want. So we want this action to happen over time, or happen until it reaches the agent, and execute when it reaches the agent. It kind of felt logical to put in here, but there's a built-in system for it with move system. So we go to the follow action, click on the move data, just make it required. And for now, the destination transfer, I'm just going to drop in this player. This almost works immediately, except if you press play, you will get errors. This error happens because there's no move system at the moment, so you get an error here. This system is purposely built to show you error if you have an error. I don't want you to gracefully fail. So that error message was complaining about lack of move system, which is what we need to implement. I have an example system called mesh move system. It's move system mesh example. Noah is a flying type, so we won't be using this. So we'll be making our own. So I'm going to go back to the follow action and just make a class under it. This is just so I don't have to retype it in space. Fly move system, I'll call it. And we have our move system base. By default, you need to implement the member. When does it reach the destination? Set. And so forth. I'm going to turn this into its own class now. So we need to set the destination. We need to set the properties, like speed and stuff, and stop. So this means this class. So with the nav mesh example, we didn't have to use an update loop because nav agent is already a moving agent that handles itself. So we need to build a way of moving as well. So let's make a method. Let's make an update loop. And in this update loop, we just want to tell if there is a destination. Here's the destination. That's it. So I'm making these public so you can see it. Destination. So when we set destination is just gonna equal destination. Set destination is called by the agent. It gets the location from the action and it calls this. So this comes from your action. Remember how earlier we under follow just directly reference the player? That's pretty much that. So if we call stop, I'm just gonna have it as destination equals false. And then if you're setting destination, then has destination is true. Now we reach this destination when it reaches stop distance. Now we're gonna try to have public flag for stop distance. And this is equals 1.0 f, that's the default. Now bar distance equals 53. That distance from, I'm gonna go from transform dot position to the destination. Now if distance is less than or equal less than or equal to stop distance, will return true. Otherwise, return false. just gonna use convert it to the logic. I like writing it out very logically and then convert it and see if it still looks nice. You can split it back, but I think this is quite easy to read. So now what I want to also talk about is this. You may not want to use this particular line move system transform precision public agent and use agent.transform.precision. In fact, let's do that so that we don't have a problem with it, because you might not have this on the actual agent. So when you're moving, you need a speed, right? Public move speed. I'm just gonna set it to 2 by default. So we'll just say move speed equals move data dot speed dot move speed dot speed. So it has other that we can use, like stop distance. Let's use that as well. I'm not going to be building angular speed and acceleration, so we'll ignore those values. So stop distance equals move data dot properties dot stop distance. So this will all pass down. The last thing we need to do is implement this. So if has destination, then we'll just simply say agent that transform that position. I'll just move towards. I can use negative basically, but I tend to like to do it by working out the delta. Destination minus. So rather than delta, I want to do the direction. Speed. So now this destination will move. Otherwise, it won't move. So that should. This is the properties is null here, so we just need to create our own property as well for the move data in action, and you can reuse them. So right here. So the move system, and we're gonna create some properties for it. I'm gonna call this normal movement data, and then attach that over here. And in it, we can choose the speed and the stop distance. I'm just gonna keep 3 meters away from the player. The last thing we need to do is attach a move system. For our move system, select our agent. Doesn't matter what the move speed we set, it will be modified. Now when I press play, I have an error. That's because I forgot to drop this into the move system. So let's press play again. You can see now no one moves over there immediately. Very fast. I'm going to make it a bit slower so we can see it. I'm going to move our console over here. Set this to maybe 2. And I'm going to press play. You can see now he moves over there. And the player, as I move, now will move with him. Obviously, this is not very amazing, but this shows how you can set up one action. Let's complete this fully. Right now, in our consideration, we hard-coded this response. So I'm going to show you 2 ways of setting this up. 2 ways? There's 3 ways. So we can use either property set or attaching a game context. So I'm going to show the game context way and the property way as well. So public class. This is the Noah demo context, but it'll actually be your game name context. So we call Noah example context. It will be mono behavior, and it will implement agent data. Wrong thing. Agent data context. When you implement this is automatically found by the agent, and the classes such as consideration gets access to this context. So in here I can literally just say companion this command type, and this is the current command. It's almost that simple. And you can go to your command consideration, and change this pretty much to agent.getContext of Noah example context dot current command. So this method is here. This method here is might be why you will want to do the other method that I'll be showing next. This isn't too bad. What it is it tries to get the context that you pass in the t, and it will cast it over. So you are incurring a cost here, which you might want to like create instead. Maybe public class game manager, and your game manager would have. So this is another way you can access the data and avoid the casting if you want to. Agent one data. You can obviously make this a lot better than this. But let's just show you an example of how to replace this. You go agent, you can go game manager, instance, agent data, current command. And that gets access to this. Obviously, you will want to make this an actual singleton. And in my case, I will be sticking with the original method, so I'm just going to undo until I get back to there. The cost you incur from it is almost nothing because it gets called once every now and then. So if your agent is constantly rethinking, like every frame literally, it might be a bad idea. But if it's every few seconds, the casting is harmless. And I'll show you another way that is built into the system where you don't need to cast. So let's just confirm that works first. So let's attach the context again that we just built. The Noah example context. Noah example context. Now the current command is none. You see Noah is not following. The score is 0. So if you ever want to know why your agent is not doing something, select your agent, look at the agent class, search for the agent debugger section, and click the follow. Well, not click the follow. Look at the action section. See the score? You can click on it to expand it for more info. You can see here it's available, but the consideration score for the command is 0. Now let's change this to follow. I actually hope this works, and it does work. You can see the score is 1. And it's going crazy here because it's constantly trying to get there. And let's fix that up too, because you don't want it to try to follow and then complete immediately. Your animation will go out of whack. So you notice here is available is always true. We actually want to override that and say, hey, if you're already in the distance, all score is 0, don't bother. So if score... Actually, I think this approach would be bad, so we just have to rebuild it. The destination is your data decision. Now I'm going to show you something else too, because you will notice that you don't have access to the actual vector-free destination you're going to, and only that. So this is actually not right. Let's just stick to that for now. So this just confirms if you've reached the destination. So if reach destination, return false. So that you stop moving. Ooh, that's hard to, that's annoying to read. I'm going to leave it as this. So I'll show you how to remove this after we confirm it works. Understand the problem. Now we can go to context, set to follow, and hopefully it works. And yeah, it works. So it reached and it stopped because this action is not available. Now I'm going to move the player. And wait for complete to happen again. Cool. That's the end of this video. In the next video, we'll be adding the other commands. Welcome back to Utility AI Framework. In this section, we will be adding an extra action to Noah. It will be telling him to sit after receiving the command sit. So before we do that, I want to cover a topic I mentioned earlier, or in the last section, with the consideration the follow command consideration, how it accessed the NOAA example context. I mentioned that there was another way of getting it that is pre-built into the system. So the current get context, we incur the cost of a cast, which you might not want to do, depending on how, I guess, sensitive to performance you are. In the last lesson, I showed another way, which was to use a singleton. And in this lesson, I will show a built-in way with the system. So let's get out here, and I'll just select a folder where I want to make some data. So I'll right-click, go Create, Timmy Studios, Utility AI, and Properties. And we can make something called Property Set. So I'm just going to call it NOAA Property Set. A property set is basically, it contains a collection of variables pretty much. And in our case, we can create a new variable under int property and just call it current command and name it as 0 or none. Now, to assign this to the agent, we need to select the agent, look for property set, and assign it to the agent. Now, if we go back to our has command consideration, we now have a way of getting rid of this. So I'm just going to comment that entire line out, and I'm just going to get agent dot property set dot get instance. We want to get the instance, not the original, because a property set is a scriptable object, and if we get the original and not the instance of it, we can modify data when we don't want to, because it persists in the project file. Anyways, once you get the instance, you can get the int property set, and then you can go and actually try get the value out of it. And earlier we call it current command. You can make this a constant, and it'll be much less chance of an error. Command index. This is a try get, so you can do it if it exists, then you do that if you want to, but for now we know it exists. So we now can say var command received equals e command received e companion command type of command index. If you feel that is still not performant enough, you can do a public dictionary of int to e companion type table equal e table. And then, then it'll be 0, then 0 will be none, yada. Follow. Let's just try that. 0 and 1 follow, and we'll just use it on the type table instead of a class. Oh. Command index. Cool. So what we've done here is we created a dictionary table of 0 meaning none, 1 meaning follow. So now, and we are getting the property from the int table or int property set of current command. So we go back to the editor now. Just making sure I've saved this good. Back to the editor. Yeah. We should be set to just press play. Here you can see it created an instance, and in the instance there's a current command. When we change it to 1, it follows, and it completed it. We can move our player around, and it continues to follow. Now, this is okay, but it's very aeroplane. It'd be nicer to have a drop down, and in the future I plan to make this the name here drop down too, but we need to build a concept of a domain. But in the end it'll just be a string, so I'm keeping it as that for now, for launch. Anyways, what we're going to do now is we're going to change this value type from an int to the actual enum and avoid having to create this table. So let's delete this whole table because it's unnecessary. Delete that too, and we're left with this situation right now. We're gonna be creating a new property set. So instead of an int property set, it's gonna be a command type property set. But we don't want to modify this class. So I made So we'll make a new C# class called null property set asset, but we'll make it a partial class of property set asset instead. If you're not aware, or if you're new to partial class, when you add the keyword partial next to class, it be like multiple files combined into as one. So this is good for our case where you wouldn't want to modify existing source code, because when you update a package, things can go very wrong. So we use a partial class here. Now, once you do that, we want to start mimicking the setup for the int property set. So I'm just going to copy that over here, literally, and then rename it to companion command property set, and like that. Now we need to make a companion property set. So click companion property set. If you forget how to do it, I highly recommend just going into an existing property set, such as the int property set, and just look for. You can copy and paste this. There's nothing wrong with copy and pasting this. Copy and pasting this and following the pattern in it. I'll explain it anyways. So you make the name of the property set you want. You inherit property set and pass in the property set of the type you want. In our case, it's the companion command type. And you want to mark this class as serializable so that it shows up in the editor. Just like that, we're almost done. The only thing with these property sets is you have to initialize them. Under the hood, we set up a lookup table for it. So you just need to call initialize. For that, you can implement a partial method called initialize additional properties. And you would call companion command property set dot initialize. And that will initialize it for you. Now we go back to the Unity editor. We still have an error. This is because we don't have a command receive yet. Here we're getting the int. We no longer need to get the int property. We're going to get the companion property set. And we're just going to output a command receive. So this way you can strongly type and also just add more things to the project or to the original system without having to touch the source code. So now we actually have a new property set, and in it we're just going to add the current command and leave the type as none for now. And I'm just going to remove this because we don't need it anymore. Just hit save and press play. Now click on the agent. When the instances will decline, double click on it. You can change that to follow, and it follows. Great. So let's use the same pattern and create the sit behavior. So I'm going to create a new game object called sit actions. I will now make a class called sit action, public class sit action. And I'll mirror the old method in the sense that we'll just implement utility action as I did it. And again, I'm just going to return the action status dot complete and move it to its own file. So with the sit action, for now again, I'm just going to go debug.log sit. Instead. Cool. Now that we have an action to start with, we want to build the consideration for it. So here we have the follow command consideration. We can just duplicate that and rename it to sit command, because all it's waiting for is to receive a command type. Sit command consideration. So should it sit or not? Now we'll just change this to sit. Stay. What the command type is. And then click on your sit action game object and add the sit action. Rename it to sit. Again, Unity had in this version, because it's a beta. Oh, sorry, it's not LTS. It has some bugs. In our considerations, just add a new consideration of sit command consideration. Move data, we don't actually want sit to move anywhere. We're just going to play a method or an animation, so we don't actually need to check this box. We don't need a property set for sit action because we're actually using property set in the agent. Yeah, so I feel like that's actually how easy it is to add a sit action, and the rest is just animation code or tweening code. So just to show that it works, let's open up this, change it to follow, change it to sit, and it's constantly saying sit. That's pretty cool. It's that quick to add a command, the sit action. Now we can tell now what to actually do with sit, but we'll have to program in the functionality for it. Yeah, sure, let's do that. Ground point equals, so we're really just getting the ground point from my position. It's gonna be agent dot transform dot position. Distance from ground is gonna be 0, and we'll pass in the ground layer mask. Okay. Ground mask. That's cool. Sure. Invoke it as an extension method. Now you don't. So now I'm actually just gonna go agent dot transform dot position equals ground point, just to make sure that we are actually correct. Let's go back to Unity. Let's play. Let's click on the agent. Let's click on the plane. Change this to state. It won't stay because we don't actually have a ground yet. Let's create a ground. We have a ground. Let's give it a layer. In my game, I'm just gonna call it terrain. Then under your action, the fit action, the ground mask, I'm gonna mask with the terrain. Now Noah, I'm just gonna bring him a little bit higher. And press play. Now go to the property client and click play. You see that he straight away goes down. Now that's pretty cool. But we want to now get him to animate over time. So we're gonna go maybe there's many ways we can do it. Let's go direction equals ground point minus agent dot transform dot position direction dot normalize. Then get agent dot transform dot position as equals direction times counter delta times speed, and speed's gonna be just 2 for now. And then instead of returning complete, we need to check if it reached this destination or not. So if we go var distance equals vector 3 dot distance between the agent dot transform dot position and the ground point. Now if distance is less than or equals to stop that distance, and I'm not making it as a variable because it's just for type purposes. I'm gonna say 0.5. Then you return the action status complete. Else else will return running, and that's how you keep the process or the perform action continuously running. I'm just gonna convert this to this because that generally reads okay. I'm gonna remove this part here where I'm setting the position immediately. Now, so this now should slowly sit, and the sit is complete when he actually reaches the ground. So again, click on your AI, click on your instance, and click stay. You can see he sits down and he does it. Now, if you don't know if the agent actually completed the action, you can turn on the show log and click on maybe the complete status or log type because you want to see if it completes it. Change that to stay, and you can see it will call it complete. Now you can see here it's constantly calling it. So we want to remove that again too. So we want to again override is available. And here you see, yeah, it's kind of duplicate of that. So I'm going to duplicate it for now, but we'll refactor it. So I'm going to get the ground point again, and we're going to check the distance. Yeah, definitely need to refactor that on that. So any utility action can get access to the agent, so we can get the agent this way too. And then we'll just return the exact same thing here, but obviously this time it's a boolean instead. So you're available if you're less than or equal to 0. Now it's opposite if you're greater than stop distance. Now let's make stop distance a float. A public variable. Now we can make distance a method for sure. Get distance from ground, something like that. Yep. Then we'll just return the distance. No, sorry, distance of flight. Now we don't need to do that. And we get distance from ground. In practice, there's no problem with it. You can keep it if you want to, but I just like to remove it. So I press play, go to the clone, go into the state, it's completed, and I won't do it again. If I move it up higher, it will want to keep going down. So just like that, we now have a follow and a sit command action. Follow,